Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, happy Tuesday to you 7th, 8th graders. And speaking of the weather and humidity, which we'll cover on Thursday. Remember, no school tomorrow, right? Woohoo! So anyway, as of late, the air has been quite dry, not a lot of moisture, so low humidity, low percentages of humidity, and because of it, you may, like me, find that your lips are drying out, your skin is drying out. In fact, my fingers actually crack this time of year when it's really dry, and I get to put these designer Band-Aids on. It looks really cool. So I know they look really cool, and I put a special healing cream on them to kind of help out. So that's why you see me with the perhaps not so cool Band-Aids on. Hey, on your tan sheet, you've all got a tan sheet. So anyway, I hear that you had a really good Monday. So keep it up. Keep it up with Mr. Phillip. He went over everything with you as far as rules and regs. So continue to really work hard at no marks on the desk, no food or drink in the room except water. That's it. So, yeah. So that'll get you in trouble if you're eating snacks and kind of sneaking around trying to eat stuff. So won't work out good for you. So, and then also NBZ, no blurt zone. So when Mr. Phillip or me are talking, not a time to talk. So he eventually is, probably the next 2-3 weeks, is going to come up with a permanent seating chart. And if you are a regular talker, you will get preference in the seating chart. What's this? Preference. Preferred seating. From our standpoint, probably not from your standpoint. So be good doobies, pay attention, don't talk, and as they say down in Australia, Bob will be your uncle. That means it'll work out really well for you. Okay? So anyway, on your tan sheet now, here's what I'd like you to write. I'd like you quickly, don't spend a lot of time on this, whether you are artistic or not, on the Gardner Intelligences list, draw quickly the 4 kinds of clouds and put their label underneath them. Quick, on your tan sheet. You're drawing the 4 kinds of clouds, which will show up on Friday's test. And their name. There's a lot more than 4, but those are the 4 biggies. We'll start from the top. Well, actually, we'll start from the bottom and work up. 20 more seconds. Just quick line drawings. No detail required. First, you have the low to the ground, pretty low to the ground, long stratus clouds, layered clouds. Stratus. Then you have the fair weather clouds that look like cotton balls or popcorn balls. Cumulus. So you've got those. Cumulus. And then cumulus clouds, if there's a lot of moisture, they'll, as they're heated up by the sun during the day, they will grow into cumulonimbus. Now, I don't care if you spelled it correctly, not that important. Over the next day or two, I'm going to talk about the kind of weather that comes out of those violent clouds. Big hint right there. So we'll talk more later. And then The high altitude clouds way up there, little wispy clouds called cirrus. So anyway, I hope you did well on those. You will see those on Friday's test. So every day, your do nows, your lesson planner comes out, your journal's out. You will write in your journal today, so be prepared for that. Okay? So those two important things. And then homework goes in your lesson planner. Your homework for tonight is to study everything we've covered, all the topics that we've covered for Friday's test. They'll be included. How many points again? 30, maybe? It might be a little bit more than that, but I'd say at least 30 points. So it's not small. It's not a quiz. So RRR. If you review, you will remember. It's a secret to being a good student. RRR. Review. Then you will remember. So RRR, all of this. What topics are going to be on the test? Here they are really quick. John 1:3, all things were made by him, and without him nothing was made that has been made. The meaning of that, Jesus made all matter. He made every atom in the universe. So I'll ask you about the Galileo Experiment, where he dropped things from the Tower of Pisa, supposedly, we think. So that experiment he lucked out on. He just happened to have two objects that were heavy enough to be pulled equally by the gravity, which normally happens in what kind of environment? I'll ask this on Friday. Vacuum. By the way, again, my MO, my reputation is to test you on things that I've gone over with you, that you have reviewed, that I've told you we're going to be on the test. I'm not going to tell you every question, but I'm going to tell you the topics, and that's what I'm doing right now. So the drop experiment. And how did it end? Gravity pulls equally on heavy and light objects. And you've got to do it in a vacuum where there's no air, so the air doesn't hold up the lighter objects. I'm going to test you on the 4 intelligences, or actually there's like 9, but I'm going to ask you for 4 of the smarts or strengths that you and I have. So here they are really quick. Art spatial, logical mathematical, musical, interpersonal, where we're people smart, intrapersonal, where we're self smart, and then linguistic or word smart, nature smart, naturalist, body smart, you're coordinated, physical kinetic, you'd end up being really good at sports. And then existential smart or God smart. So those are the 9. Then I'm going to also test you on hydration benefits again. Good things that happen when you regularly hydrate. What happens? Just about every part of your body is helped. So your brain is helped because it's mostly made of water. Cells are helped. They're 70% water. Your digestion is helped. So it's really important. Nutrients are dissolved and passed through your bloodstream to your cells. So that's super important. Your kidneys work better, more efficiently when that happens. So when you hydrate on a regular basis, your skin is helped out and it doesn't dry out as quickly. And I know I'm forgetting a few things, but there's 6 right there. And all of those need to be in your journal. I've already said the kinds of clouds, El Nino, La Nina. What kind of weather pattern do we get when we're in an El Nino? A wet, cooler pattern. A La Nina causes us to be warmer and drier, like we are now. It's why we're having a drought, because we're in a La Nina pattern. And then what happens? The jet stream, the wind, the high level wind current, blows storms in a La Nina over northern California and further north, miss Arizona, miss Southern California. So in a La Nina. By the way, in a La Nina, my relatives in Australia that are experiencing summer right now, they have just the opposite weather pattern. We are having La Nina, warmer, drier. They're having cooler, wetter for their summer. A lot of precipitation, a lot of rain coming down. So in Sydney, where my two daughters live, and grandkids down under in Australia. Meteorology, the scientific study of the weather. So I'll ask you about that. I'm going to ask you about your superpower. So I'm only going to ask you two possible things about your superpower. Your superpower is the way God designed you. It is who you are. It is the unique person He designed you to be. Your unique personality. Your unique strengths. Like the Gardner intelligences. So, what is your superpower? You. All of your unique you. And God designed only you like you are to be uniquely used in His kingdom. To have a unique purpose. It's wonderful. It's a wonderful thing to know that God designed you and you're living out the purpose that He intended for you. It's just a great joy to discover all of that and know all of that. It took me till I was about 21 to realize that. Hey, God made me this way. And He designed me to be used in His kingdom. And only I can be used in the way I am being used. Wow, that is so awesome. Such a special thing. So, anyway, and then the second thing I'm going to ask for you is, first of all, what is your superpower? It's you and your strengths. And why did God give it to you? So you could glorify Him. So you could glorify Him. Make Him look good. I'll ask those two things. What is your superpower? And what is it for? To glorify God. So I'm going to ask about all of that. Okay, I'm going to take just a little short break at this point, and Mr. Philip can give you a little pause and clarify anything or answer any questions that you might have right now that I couldn't answer because I'm not with you in person. Boy, I wish I was. I wish I was. I miss you all. Okay, Mr. Philip, short little break, and then we're back. And we are back. And what I'd like you to do, where do I have these? Over here, I think. Here they are. So I'd like you on your tan sheet to use it again. Now, when I ask you to use a tan sheet, I expect you to write on it. I expect you to answer, what I'm asking you to do. Don't fake it. Actually write. And that's one of the reasons Mr. Philip will kind of mosey his way around the room as you're writing on your tan sheet. So I want you to write. It's not an option. It's an expectation. So just like a no blurt zone, expectation, not an option. So no choice. Got to do it. It's part of being at school and being in my room and Mr. Phillips' room. So as we kind of team teach. So anyway, I have a little bit different today, Galileo Experiment. I'd like you to write down on your tan sheet every difference that you can think of in the Galileo Experiment. Every difference you can think of. I'll give you one for starters. Okay. One of the potential differences is different sizes of the objects. They're not perfectly the same size, not quite. So different sizes of the objects. Now I'd like you to think of 3 or 4 other variables or differences. I'm going to focus on the variables in the Galileo Experiment on your test on Friday. The differences. I'm going to focus on that. I'm telling you. So write down just one word variables. So you've got size. What else? other things that potentially could be different. And then I'll dump a bunch on you. Obviously, the weight of the objects. So size of the objects, weight of the objects, their mass, how many atoms they're made of. This one's hollow. This one's not. So this one's probably 3 to 4 times heavier than this one. So their mass, and because of their mass, their weight, the environment they're dropped in, a vacuum or in air, in the atmosphere, when they're dropped, what's the surface like they're dropped on. Now, if one of them's dropped on a higher surface, will it appear it hit sooner? Yeah. So you need to drop it on a flat surface. Anything else you can think of? Any variable in this Galileo experiment? I'm having a little think about that myself. I think we hit the major ones. That was about 7 variables. I'll ask you, what is the independent variable, or the one variable that's not controlled? What is it? The mass of the objects. Or I would accept the weight of the objects. The one independent variable. Not kept the same. Not controlled. Okay? So, and I might ask you for some of the control variables. Or I might just ask you, hey, what does control mean? Control means you keep the variables say it out loud, the same. Control variables, you keep things the same, S-A-M-E. So anyway, a little bit more about the Galileo experiment and the test. So anyway, cool. Now, time-wise, I'm in really good shape. So I want to teach you a couple of additional weather things and then some more tomorrow. Now, I'm going to tell you some stories. I think you're going to like this, that match what I'm teaching you. Okay? So this goes in your journal. You're going to see a photo of this to start with. Many of you know this already. This is the water cycle. It's God's way of moving. It's like God's conveyor belt of moving water from the oceans over the land to water the land. It's how he does it. And you're going to need to put in the objects that are involved in the water cycle. And you'll see them in this photo that you're looking right now. The sun, you've got to have a heater to heat up the water from the oceans. So you need the sun. And it acts like a heater. So the water is heated up, and the first ION word that happens is evaporation. The water is heated up, the droplets become smaller and move further apart, and then they become so light that they go up. Evaporation. And then the higher you go in the atmosphere, the cooler it gets. So they get cooled and they condense back into heavier droplets of water. So evaporation. Condensation. They form clouds. So draw in a cloud. Evaporation, show the water droplets going up. Evaporation. You can see it spelled there on the visual you're seeing. Condensation, they're cooled down. Condensation with C, they're cooled down with C. The water is cooled down, and it forms clouds. Clouds are condensed water droplets. Gazillions of them. And then when the water droplets get heavy enough, the third ION word. Evaporation, ION. Condensation, ION at the end. And then precipitation. Now, the way God moves things over the land is this: evaporation, 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 condensation, and then the wind patterns or jets, the jet stream, blow those clouds, those big groups of water droplets over the land, usually up over the mountains, and then it falls as precipitation. Rain, snow, sleet, hail. We'll go over the kinds of precipitation in just a little bit. So water cycle again, you've got the sun, which heats the water up, evaporation, condensation, clouds, drawing clouds. Show an arrow for the clouds moving over the land. Maybe draw coming up out of the, so you've got the ocean, and then showing the land coming up near the ocean. Up comes the land. Show the clouds moving over the land and the precipitation falling on the land. And then it runs off, pulls down, runs off into the lower areas of the land. This is the way Arizona gets its water, from the Paco, from the Pacific Ocean, Paco. It evaporates, it's cooled, it condenses. The jet stream blows it over Arizona. It precipitates over the mountains, runs off into the reservoirs and lakes where we store it, then into the canals, and then it's cleaned up at the water treatment plants. Chlorine is added, it's filtered, and then it's passed underground in our pipes, underground in our cities, and comes out our tap. Okay? So anyway, the water cycle. I'm looking for the major things: the sun, the ocean, evaporation, condensation, precipitation. That's what I'm looking for. And then showing it blowing over the land. And I'm looking for runoff down the mountains, runoff. You might want to draw in our reservoirs or our lakes. So there you have it. It's the, what's this? The water cycle. It's the water cycle. Now, above cycle, I'd like you to draw a circle. Water cycle. It's ongoing. Keeps on happening. It's God's way to make this happen since He created the earth. Water cycle, cycle, cycle. Keeps on happening. Did you write cycle in your journal? You should have written water cycle. And then up above, it's ongoing. It keeps on happening. Okay, the water cycle. Okay. So, by the way, do you see the relationship here? We've got water, we've got hydration, living things God made of mostly water. Plants are made mostly of water. Animals are made mostly of water. We're made mostly of water. So the things we eat, plants, made of water. The meat that we eat from animals, made of water. We get about 20% of our water that we take in from our food. About 20%. Now you've got to glug, 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 glug the rest of the water that you need to intake. And that's where hydration comes in. So, now I want to teach you 4 of the kinds of precipitation and tell you a few stories related to precipitation. There's 4 kinds of precipitation. You're looking at a photo of different kinds of precipitation. There's rain. You'll want to put these in your journal. 4 kinds of precipitation. Precipitation. It precipitates. Comes out of the bottom of clouds. Rain, snow, sleet is like frozen rain. It's bad news if you've ever been in a sleet storm or frozen rainstorm. It coats the roads, so people slip and slide everywhere, and there are usually a lot of accidents during a sleet event. I'm trying to think. I don't think I've ever been in a sleet event before, but I've been driving on roads where there was snow that was plowed off the roads, but they didn't get it all, so it was real slippery. And one day in Grand Forks, North Dakota, I pulled up to a stop sign with a layer of snow underneath that I think had turned to ice. It had melted and then frozen. I'm sitting there at the stop sign in my lane, and I just start sliding over to the other lane of cars. What do? Well, you hit the brakes. Did I stop? Yeah, thankfully I stopped. But that would be like in a sleet storm, frozen rainstorm. You just slide and you can't stop it. Hitting the brakes doesn't do the job like it did for me, fortunately. So rain, snow, rain, snow, sleet, and hail. Now we get the rain, we get the snow, just frozen water droplets when it's cold enough. Now I want to show you a picture of what it looked like in one snow blizzard that we went through in South Dakota. It snowed so much, and it blew into huge mountains of snow called drifts, so much that, like this photo that you're looking at, there was a tunnel. We actually, coming out of our door, we had the snow piled up so high it was way up above the door. And we actually dug, as we dug out the sidewalk, we dug a tunnel and you could walk through it with snow up on top of you. That's how much snow came down. How much snow did you get? I don't know, probably 3 or 4 feet of snow. And it blew into drifts that were over 10 feet high. So amazing. So probably the most amount of snowdrift, snow piles that I ever saw in North Dakota and South Dakota. And then another story for you. In fact, a couple of stories to wind things up today. It's about hail. Now, you know what hail is. You are looking at some hail balls right now, a photo of some hail balls. Hail balls are just, they're like balls of ice. How do they form? Here's how they form. Usually you've got a very violent kind of cloud. What would that be? Cumulonimbus, of course. A cumulonimbus cloud. But these are the biggest of cumulonimbus clouds that tomorrow we'll talk about, that also form tornadoes. So in a cumulonimbus cloud there are high winds. Often winds that are updrafts. Oh, I think I see how hail stones or hail balls might form. You got it? You think you know? So you get a raindrop formed, and the rain starts to fall, but the updraft, the high winds in these violent clouds, cumulonimbus, shove that raindrop way up into the cloud where it freezes and forms a small ball of ice, and then it starts to fall. Got heavier, starts to fall. But the updraft is so strong, it shoots that hailstone back up into the clouds. It gets another coating of water, and then it goes way back up really high and it freezes. So it gets bigger and bigger and bigger and bigger. Depending on the number of times that it falls, gets another coating of rain, and then it's blown way back up where it's cold into the cumulonimbus cloud. And that layer of water forms. And in hail balls, you sometimes can see these layers of frozen water that accumulated. And then eventually it gets so heavy that it can't not fall to the ground. So it falls to the ground as an ice ball. Could be marble size or smaller, getting bigger and bigger, golf ball size, getting really big, baseball size, and the most massive softball size, about 4 inches in diameter or bigger. The biggest hail ball ever measured was 7 inches in diameter. Wow! And you don't want to mess around with hail balls that are falling to the ground and be out in it. I mean, if it hit you in the head, it could knock you out or even, cause you to go to heaven. So you don't want to mess around with hail. Now, when I was about 9 years old, I was in a baseball game in South Dakota. And this real weird-looking yellowish cumulonimbus cloud came over. A lot of lightning and thunder. We kept playing the game because it was off in the distance, but moving our direction toward the baseball field. So I'm out in left field, and the scoreboard is beyond the right field fence. And I'm looking over there. Good thing they didn't hit a line drive my direction. And I'm looking over there, and someone is throwing ice off of the scoreboard. The scorekeeper must be throwing ice. No, he wasn't. No. What was it? Hail coming out of that yellowish, very violent cloud that moved over us, moved over the ball field. And then the hailstones started to fall, or hail balls. What did we do? We made for the cars as fast as we could and just piled in. Wasn't even people's cars, and just as many people piled in as possible. Because the hail balls had gotten bigger than golf ball size. Not baseball size, but bigger than golf ball. They were really big, really big. And some people got hit with them, like in the back, and it made huge welts. Fortunately, no human was injured. But the cars were injured, damaged, big time. I'd say, 100 or more cars were hit with these golf ball plus size hail balls, and they caused dents in the roof. And you could hear them hitting. I mean, really loud, scary, really scary. So, and permanent damage to the roofs. They had to have body work. Insurance had to pay for it. So, in car insurances. Anyway, you don't mess around with hailstorms. You just don't. Coming out of cumulonimbus clouds. So, 4 kinds of precipitation: rain, snow, sleet, frozen rain, and hail. There are other kinds which you can see on that chart, but I just want you to know those 4. And yes, they will be on the test. Now, your homework tonight is study all of this for the test, the topics I went over. So study this tonight, Tuesday night. Wednesday, no school. No homework for Wednesday unless you want to study. It's optional. Unless you want to study for Friday's test. And then I'll see you back on Thursday. And so will Mr. Phillip. So right up front, he's going to answer any more questions, additional questions you might have. So thank you, Mr. Phillip. And I will see you on Thursday. Adios.